Hello. Today our notes are on 1.4 sets of numbers. I know you all did this at the beginning of 8th grade because remember that's what I used to teach. So let's begin. Our natural numbers are our numbers when we count 1, 2, 3, 4. Those are also sometimes called our counting numbers. Whole numbers, we add 0 to the mix. 0, 1, 2, 3, 4. And then integers are positive and negative whole numbers. So, and all of those are part of the set of rational numbers, which rational numbers can be expressed as a over b, where a and b are not 0. So we also learned last year that it's a fraction of integers. Okay, square root is one of two equal factors of a number. One square root of 64 is 8, since 8 times 8 is 64. Non-negative square root is called the principal square root. Another square root is negative 8, because negative 8 times negative 8 is also 64. Remember, it's really important when we're squaring to have those parentheses. Number like 64 is a rational number, or called a perfect square, because when we take square root, we get a rational number. There are numbers like square root of 3, which is not a perfect square and cannot be represented as a terminating or repeating decimal. Therefore, this is what we call irrational numbers. Irrational numbers cannot be written as a over b, where they're both integers. It cannot be written as a fraction of integers. And the whole set combined is real numbers. And I know you all saw this before because it was in fact the back of the very first quiz you took in 8th grade math. I know that seems like a really long time ago. So classifying real numbers. Name the sets of numbers for which the real number belongs. So letter A is a fraction, so it's rational. And it's also real. B is the square root of 81, which is 9 or negative 9. Therefore, it's an integer. It's rational. And it's real. Because remember, once you're in the soup pot, you stay in the soup pot. So integers are part of rationals, which are part of reals. Square root of 56 is irrational. It's a never-ending, non-repeating decimal. Also, it cannot be written as a fraction of integers, so it's irrational and real. So to graph a set of numbers means to draw a plot of the points that show the numbers. Number corresponds to the point on the line called the coordinate. So this is where we're just estimating where it is. So 5/3 is a little bit more than 1. It's actually 1 2/3. So this point right here is 5/3, because our number lines broke up into thirds here. Negative 4/3 is negative 1 1/3. So it's right here. 2/3 start on 0, 1/3, 2/3, and negative 1/3 start on 0, go left. Negative 1/3. Letter B, notice our number line here goes from 6, 7, 8, and there are 1. There are 10 spaces. So 6 4/5 is the same as 6 8/10. So that would be right here in between 6 and 7, closer to 7. Square root of 49 is 7. It would also be negative 7, but we don't have that option. 6.3 repeating is not 3/10, but a little bit more than 3/10, because it's 3, 3, 3, 3. So here's 3/10, so I'm going to go a little bit more to do 6.3 repeating. Square root of 57, I'm going to use my calculator to approximate what that is. I know that it's in between 7 and 8, because 7 squared is 49. 8 squared is 64. It's in between that. It's actually 7.549 more stuff, so it's about 7.5. A little bit more though. So I'm going to put it right there and I'm going to leave it square root of 57. Okay, you try letter C, come back. Again, I'm going to estimate square root of 20 on my calculator. It's 4.47. Here again, I have 10 spaces, so it's in between 4.4 and 4.5. So it's approximately right there. 4.7. 12 thirds is really just 4. 4 and 1/3, again, that's not 0.3, that's a little bit more than 0.3. And that's the end of today's notes. Please do the additional practice. We'll do the additional practice in class. Please bring any questions you have to class tomorrow.